Hello everyone, welcome to Helm of Science. So I hope that all of you are safe. So in the previous video, we have discussed the concept of continuity of class 12. So I hope that all of you have understood the concept. So today we will do some important problems related to continuity. So the first question that is given, it is f is from R to R, defined by fx. It is given 2 sin x minus sin 2x by 2x cos x if x not equals to 0 and a if x is equal to 0. Then find the value of a so that f is continuous at x equals to 0. Now, for continuity, if a function fx is continuous, then what we say that when a function fx is continuous at x equals to a, what we say LHL, that means left hand limit equal to right hand limit equal to f of a, that means functional value of the point, that means functional value equal to a finite quantity. Okay, so this is the definition of continuity. Now here what is saying, it is fx defined by 2 sin x minus sin 2x by 2x cos x if x is not equal to 0 and a when x is equal to 0. Then find the value of a so that f is continuous. That means we have to find the value of a for which the function fx is continuous at x equals to 0. Okay, so here it is given that the function is continuous at x equals to 0. That means LHL is equal to RHL and it is equal to f of a. Okay, so here we do not have to find the LHL RHL separately. We can write limit extends to 0 of this function, that is when x is not equal to 0, then limit extends to 0, then we will take this function, that means 2 sin x minus sin 2x by 2x cos x, and when x is equal to 0, that means f of 0, which is a. So we will write in this way that here f of 0 is actually what? A, which is a finite quantity. Okay, now since the function is continuous, so we can write here that limit x tends to 0, okay, 2 sin x minus sin 2x by 2x cos x equals to f of 0, that means equal to a. Why? Because since fx is continuous at x equals to 0. Okay, this is the condition. So we have to find the limiting value of this, that means 2 sin x minus sin 2x by 2x cos x. So let us find this. So it is what? Limit x tends to 0, 2 sin x minus sin 2x by 2x cos x. Okay, now it is limit x tends to 0, it is 2 sin x minus, what is sin 2x? Sin 2x means we all know that it is 2 sin x cos x. Okay, by we have 2x cos x. Okay, now it is limit and speed x will be common, so it is 6 by, so if we write this in a proper way, that means limit x tends to 0, it is sin x by x. We will take sin x into x in this way into 1 minus cos x by cos x. Okay, now since this 2, that means sin x by x and 1 minus cos x by cos x is a defined function, so we can write in the next step, that is limit extends to 0 sin x by x into limit extends to 0, because both the function are existing finitely. So we can write this. So it is 1 minus cos x by cos x. Okay. So what is the value? Limit extends to 0 sin x by x, we all know it is 1 into. Now it is what? Limit extends to 0, 1 minus cos x by cos x. 1 minus cos x. Cos of 0 is what? 1. So 1 minus 1 by 1, it is actually 0. So ultimately the value is 0. Okay. So we have got the limiting value as 0. Now we have to write, since fx is continuous at x equals to 0, therefore limit extends to 0 to sin x. We have already written in the first step, but still it has to be written in the last step. So it is sin 2x by 2x cos x equals to f of 0 equal to a. That means, what is the value of this? What is the value? We have got that it is 0. So we can write a equal to 0. Okay. So the required value of a for which the function fx should be continuous. Here we have to find that. That is the value of a for which fx is continuous at x equals to 0. So we have found that a equal to 0. That means when fx is continuous at x equals to 0, the value of a is 0. Okay. So required value of a is 0. Okay. So let's move on to the second question. Now, what is said here? Fx is defined as mod sin x by x when x is not equal to 0 and 1 when x is equal to 0. Examine whether the function is continuous or discontinuous at x equals to 0. Now, we already know, all of us know that y equal to mod x is actually what? It is x when x greater than 0, minus x when x less than 0, and 0 when x is equal to 0. Similarly, here we have been given that mod sin x by x. So we can write that mod sin x is what? It is sin x when x is greater than 0. Because why? Because sine of anything negative actually what? Sine of minus theta means what? Minus sine theta. So here it is actually this concept. That means mod of sine x is sine x when x is equal, when x is greater than 0, and minus sine x when x is less than 0. Anything negative, so sine of anything negative is minus sine. Okay. So it is minus sine x, and 0 when x equal to 0. Okay. Now it is given fx equals to mod sin x by x when x is not equal to 0. Examine, and 1 when x equals to 0. Examine the function is whether the function is continuous or discontinuous at x equals to 0. Okay. So here we have to find the LHL and RHL separately so that we can get the concept that whether the function is continuous or discontinuous. So let us take the LHL first. LHL of fx at x equals to 0. Okay. So it is actually what? Limit extends to 0 minus. 0 minus means mod sin x by x. Okay. So it is actually what? X tends to 0 minus means x is less than 0. That means limit extends to 0 minus. It will be mod sin x will be what? Minus sin x by x. Now minus 1 is outside since it's a constant. Now limit extends to 0 minus sin x by x. So this is actually what? This is 1. So minus 1 into 1, that is minus 1. Okay. Now we come to RHL. RHL of fx at x equals to 0. That means what? Limit x tends to 0 plus is mod sin x by x. That means when x is 0 plus, that means limit x tends to 0 plus means x is greater than 0. Okay. So it is what? Limit x tends to 0 plus mod sin x will be sin x only by x. So this total is actually what? It is 1. So from this we can see that LHL is -1 and RHL is 1. So therefore we can say that LHL is not equal to RHL. Okay. So if LHL is not equal to RHL, then there is no concept of there is no question of continuity of the function at x equals to 0, because for the function to be continuous at x equals to 0, what is the criteria? It should be LHL equal to RHL equal to f of x. So here LHL is not equal to RHL, then there is no question of continuity. That means we can write that fx is discontinuous at x equals to 0. Okay. Now we come to third question. So what is said here? Fx is equal to kx plus 5 when x is less than equal to 2 and x minus 1 when x is greater than 2. Then find the value of k for which fx is continuous at x equals to 2. This is a similar type of sum in just as the number 1 sum that we have done. So here it is what? It is told that fx will be continuous at x equals to 2. Then what is the value of k? Okay. So here at first write that f of here f of 2 is actually 1. Since it is here x is less than equal to 2, that means we will take this function. Okay. So it is actually what? 2x in the place of, sorry, in the place of x we will put 2, that is 2k plus 5. So it is a finite quantity, obviously. Okay, finite quantity. Now we have to find here LHL and RHL. Okay. Okay. So here it is said actually fx will be continuous at x equals to 2. Okay. So if we here write the LHL means limit x tends to 2 minus of fx. So when it is less than 2, this function we will take. Okay. So it is limit x tends to 2 minus kx plus 5. That means 2k plus 5. Okay. Now we take the RHL. It is limit x tends to 2 plus of fx. That is limit x tends to 2 plus. When it is 2 plus, it is greater than 2. That means x minus 1. Okay. So it is x minus 1. So it is actually 1. Okay. Now, since it is given that fx will be continuous at x equals to 2, that means LHL will be equal to RHL and equal to f of 2. Now f of 2 and LHL is same. Okay, this is same. So we can write here that since fx is continuous at x equals to 2, that means LHL equal to RHL equal to f of 2. Okay, so we can write here that 2k plus 5 equal to 1 equal to 2k plus 5. since f of 2 and LHL is same. So from this we can write that 2k plus 5 equal to 1. Okay, from this what we can write, that is 2k equal to minus 4, or from this we can write k equal to minus 2. Okay, so the required value of k for which fx will be continuous at x equals to 2, it is k equal to minus 2. Okay, so required value of k equal to minus 2. Okay, now let's move on to the fourth question. What is said here? It is given fx equal to 1 minus cos x by x square when x is not equal to 0, and 1 when x is equal to 0. Here we have to prove that fx is discontinuous at x equals to 0. So here we will find, that means here we will find the limiting value of this function. That means when it is x tends to 0, we have to find the limiting value of 1 minus cos x by x squared. So let's find this. So if I write here that limit x tends to 0, 1 minus cos x by x squared. Okay, so it is actually what? If the limiting value is equal to 1, then this function is continuous, and when it is not equal to 1, then it will be proved that fx is discontinuous at x equals to 0. So let's see that what the limiting value comes. So it is 1 minus cos x. That means what? Now see, 1 minus cos x means what? It is 2 sine square x by 2, by we have x squared. Okay, now from this we can write it is limit x tends to 0, 2 sine square x by 2. Now since it is sine square x by 2, so if I want to get the form of limit x tends to 0 sine x by x, so what should I do? We will take here x square by 4. Why? Because we will have now sine x by x form. Okay, for this. So I have taken a 4 in the uh, denominator. So it is actually what? I have to multiply with 1 by 4, since I have taken 4 extra. Okay, so it is actually what? Now 2 and 4 is constant, so 2 by 4 will get outside. Now limit x tends to 0, it is what? Sine square x by 2 by x square by, sorry, by x by 2 whole square. We will write like this. Okay, so it is what? Half into limit x by, limit x tends to 0, it is sine x by 2 by x by 2 total whole square. Now here you see x is tending to 0, so x by 2 will also tend to 0. Okay, so in the next step we can write that limit x by 2 tends to 0, sine x by 2 by x by 2 total whole square. Okay, since for limit x tends to 0 sine x by x, this and this should be same. Okay, for that we have write this. Now for that I have written limit x by 2 tends to 0, sine x by 2 by x by 2. Okay, so this total is actually what? This whole thing, that means limit x by 2 tends to 0, this limit x by 2 tends to 0, sine x by 2 by x by 2, then whole square, that means 1 whole square. So it is actually what? Half. So limiting value of this function at x equals to 0 is what? Half. And the functional value, here you can write that f of 0 is actually what? It is 1, which is finite. But limit x tends to 0, f of x is not equal to f of 0. So when it is not equal to f of 0, that means fx is discontinuous. That means not continuous, or you can say discontinuous at x equals to 0. Okay, so this proof. Okay, now we come to the last question, that is the fifth question. So it is said a function fx is defined as fx equal to ax plus 1 when x is less than equal to 3, and bx plus 3 when x is greater than 3. Now it is said if function is, that means if fx is continuous at x equals to 3, then find the relation between a and b. Now here, what is f of 3? This is x is greater than, that means x is less than equal to 3, that means this function we will take, that means f of 3 will be 3a plus 1, which is a finite quantity. Okay, now since it is told that function fx is continuous at x equals to 2, that means what? Since fx is continuous at x equal to 3, that means here LHL will be equal to RHL will be equal to f of 3. Okay, now f of 3 is actually what? 3a plus 1. Now if I find LHL here, limit extends to 3 minus, when it's 3 minus, that means less than equal to 3, that means this function. Okay, so ax plus 1, that means what? Limit extends to 3 minus, if I put here, actually it is limit extends to 3 minus ax plus 1, that means it is actually what? 3a plus 1 from the concept of limit. Okay, now we find RHL, limit extends to 3 plus, so when it is 3 plus, it is greater than 3, that means bx plus 3. So it is what? 3b plus 3. Okay, now since function is continuous, so we can write that 3a plus 1 equal to, that means LHL equal to RHL equal to f of 3. Now f of 3 and LHL is same, so we can write that 3a plus 1 equal to 3b plus 3. Okay, we can write this, or from this what we can write, 3a minus 3b equal to 3 minus 1, or 3 into a minus b equal to this what? 2. So this is the required relation between a and b, that means 3 into a minus b equal to 2. So the question was this, that we have to find the relation of a and b. Okay, so we have got the relation, that is 3a into 3 of a minus b equal to 2. So this is the required relation. Required relation between a and b. Okay, so that's all for today. These were some important problems that we have done from the chapter continuity. So I hope that all of you have understood the problems, and I hope that all of you will be able to do all the sums from this chapter. So if you like the video, then please share and subscribe to our channel Helm of Science for more of such videos. So until then, please stay safe and take care. Thank you so much for watching.